All right, my friends. The graph of the function f, shown above, consists of a semicircle and 3 line segments. Let g be the function given by g of x equals the integral from -3 to x f of t dt. Find g of 0 and g prime of 0. Well, my friends, find g of 0. We have an expression for g of x right here. So all we got to do is plug in 0. Well, g prime of 0 is equal to -3, 0, f of t dt. This is from most negative to most positive. So I'm feeling pretty good about that. And this is from -1, -2, -3. So really from here to here. And we just got to find the area, because in order to do g of 0, we're doing the area of f of t. Well, my friends, what shape is this? This is none other than the famous trapezoid. We add different side lengths, right? We're going to do 2 plus 1 divided by 2. That's going to take into account the difference in lengths multiplied by 3, which is our width. So we're going to get 3 divided by 2 times 3. Well, quite frankly, this is 9 divided by 2. So now we know this is all equal to 9 divided by 2. Thank you very much. I'll take my 1 point and I'm satisfied. Now we got to do g prime of 0. Well, we know g of x equals this. Well, if I do g prime of x, what's going to happen to your antiderivative and derivative? Well, they're going to cancel. And in the process, we plug in the x, f of x. Don't forget, we still take the derivative of the top bound, but the derivative of x is 1, multiplying by 1. We don't need to do that. All right, let us go ahead. G prime of 0 is equal to f of 0. Now, this is just asking g prime of 0 is just f of 0. Well, what is the y value at 0? Well, the y value at 0, my friends, is just 1. Bam, that's it. Beautiful. There it is. Plus 1. Plus 1. Give me my 2 points. And let's move on to the next question. All right, take a moment to read if you haven't done so. And let us begin. Okay. Find all the values of x in the open interval at which g attains a relative maximum. Relative maximum, that means your derivative should change from positive to negative, right? So we already know g prime of x is equal to f of x should equal 0. We want to find when our derivative is equal to 0, which is just the graph of f. Well, that means the y values of f, which is here, here, and here. And we know from what we did here, g prime is just f, which is just when it's equal to 0. Now let's see, well, this down below is negative. This is positive. This is positive to positive, and then positive to negative. Just by looking at the y values, anything up here is positive, anything down here is negative. And that's just because g prime is just the y values of f. Well, which one is the relative maximum? Well, it's got to be at x equals 3 because it changes from positive to negative. So, at x equals 3, g has a relative maximum because g prime of x equals f of x. Okay, very important we use this relationship because in order to talk about g, we gotta talk about f. So because g prime of x equals f of x changes from positive to negative. Ba-ba-da-ba-bwah. Thank you very much. I'll take my plus 2 points from this problem. Plus 2 points. And we're ready to move on. All right. Crap. Part C is a pretty tough question. So I'm going to skip it for now. Let's just go to part D. Because part C is pretty tough. It's time consuming. Let me just see what part D asks. Find all the open intervals where G has a point of inflection. Okay, we know that second derivative. We're already given the first derivative, which we have here. So the second derivative is equal to f prime of x. And we know our second derivative is when it changes signs. Which means f prime needs to change signs, right? Well, let's take the derivative of this graph. Well, it's undefined right here. It's also undefined. I mean, this is zero slope here, undefined here. And that's pretty much it, right? Because we're taking the derivative of this graph. And so we want to find when it's zero or undefined. Well, when does it change signs? Well, the slope, the instant slope right here is positive to negative. Well, here it's from negative to positive. This goes from positive to negative. So if you think about it, all of these points are points of inflection because your second derivative changes sign. So find all the x values in the open interval which G has a point of inflection. Well, G has a point of inflection at x equals negative 3, 1, and 2 because G prime of x equals f prime of x changes signs at these values. Okay. Boom. Now, nothing in here set to justify. So if you were to write G has a point of inflection at x equals negative 3, 1, and 2, you would be perfect. You would be done. There would be nothing for you to do. But I wanted to write down our justification just so that you know it. All right, let's go ahead and do part C. So, absolute minimum. Absolute minimum. We got to find the absolute minimum on the closed interval negative 5, 4. Absolute minimum means you got to check your endpoints. And we need to check our critical values. Essentially, what we want is in some interval, what is the absolute minimum? Well, it could be the endpoint, or it could be where your critical value occurs. Because remember, all we have to do is do something like this. And now you check your endpoints. Well, you check your critical values. Well, now your global minimum is going to be, your global minimum here is your endpoint. The global minimum here is that relative minimum, that little U shape there, right? So we got to check our endpoints and critical values, right? And this is referencing to the biggest or smallest y value in an interval. Biggest or smallest y value in this interval of your original graph. And we're talking about G of x. Well, we already know negative 5, 4. And the good thing is, in order to find our critical values, we take our derivative and set it equal to 0. And we already know G prime of x equals f of x, which is just the original graph of y. And if you look, we got three values here. Now, it would be really time consuming to put all three critical values here, right? Well, we're looking for an absolute minimum, and we know a minimum goes from negative to positive. So it just makes sense to look at this graph and see when it changes from negative to positive from our critical values, because we're looking for the minimum. Who cares about a relative maximum, right? We don't care about any maxes. So let's go ahead. This goes from negative to positive. That is something I'm interested in because this, quite frankly, is a relative min. Here it goes from positive to positive. Here it goes from positive to negative. So we know that negative 1, negative 2, negative 3. So therefore, we know at negative 4, it's a critical value that I am highly interested in. I could care less about the rest because it's a relative maximum. All right, my friends, let us begin. Well. And what do we have here? So let's go ahead and do this. Well, we are given G of x. Well, we just plug in our values in this case, right? G of negative 5. Negative 5 is from negative 3, negative 5. F of t dt. Flip your bounds, right? Make this negative, negative 3, negative 5, f of t dt. Boom. So that's what we got right here. Negative 3, negative 5, f of t dt is equal to negative. Well, what's the area from negative 5, which is this, to negative 3? Ooh, well, I could just visualize this. These are equal triangles. 1 times 2 divided by 2, negative 1, negative 1, 1 times 2 divided by 2, negative 1, 1. All right, boom. This is negative 0. All right, we know that's 0. So we have at negative 5 a y value of 0. Beautiful. Let's go ahead and plug in g of negative 4. And before I do so, I can already tell I'm going to get the bounds, negative 3, negative 4. I'm going to have to flip them, right? I'm going to have to flip them already. So we'll just go ahead and flip them here. Boom, negative 3, negative 4, f of t dt. Now we got to just look at this graph from negative 3 to negative 4. Well, negative 3 to negative 4, we've already computed that. This right here is just going to be, this area is a positive 1. 1 times 2 divided by 2, and it's positive 1. But we have a negative on the outside, so this is negative 1. Bam. So, all right, overall, we know at x equals negative 5, we could care less about that. And I'm interested in negative 4 because my y value is most negative so far. The last piece of thing to do is find g of 4. And if we go to find g of 4, that is the integral from 3, negative 3 to 4. Negative 3 to 4. Wow, that's all the way over here. All right, well, we do know what is the area of this region under the curve. The area under this curve is a trapezoid. And what's a trapezoid? Well, we add the side lengths, 2 plus 1, divided by 2, multiplied by 1, 2, 3. So this is 3. So 3 times 3 divided by 2, 9 divided by 2, or 4.5, whatever you prefer. So I'll go ahead and write down over here. This is going to be the integral from negative 3 for f of t dt, which is equal to 4.5 plus. Okay, now we got to find the area over here. And just kind of going through, we already know just by looking at this area here and this area here are going to cancel each other out. So all we got to do is find the area under that curve right there. Now, it's a bit tricky to find the area under the curve there. So give me, hold on a second. Give me one moment to, what the heck is going on? Hey, here we go. Hey, what's going on? I want to color black. Bam. Thank you very much. Thank you for shopping. Thank you for shopping. Let me erase this over here. So don't worry, I'll probably edit this out so you don't get all fearful and have to sit here and wait and hear me talk while I do this. But, all right, beautiful. Okay, so what we have here is this, right? We got this little shape right here. Boom. And we want to find it, pretty much at this point, all we need to do is really find the area from 0 to 2, right? Because we already know this is 4.5, the trapezoid. These cancel over here, and now we're just left with that there. Well, what's the area that we're trying to find? Well, let me just draw an x and y axis. Boom. Actually, let me draw that a little better. That's much better. Okay. What's the area under the curve? Well, the area under the curve is this white part right there. And the area under this curve is this white part right here that I'm drawing in. It's the area underneath that, not this area in here, right? It's always the area under the curve, not in front here. So how do we get that? Well, I think the first thing to do is let's find the area of this box. If we find the area of this box, that'll give me at least an idea of what the area is of the total thing. Well, what's the area of this box? This is 2 times 1, which is 2. So now we know this box is 2, okay? And now we need to subtract by the area of this inside. Well, luckily for us, this is a circle. And we know it's pi r squared. And by looking at the diagram, this is pi r squared. R is 1. 1 squared is 1. So pi times 1 divided by 2. Why divided by 2? Well, the reason why this is divided by 2 is because this is half a circle, so pi r squared, but this is divided by 2 because it's a semicircle. So now I have it, 4.5 plus 2 minus pi over 2. And I'll stop there, right? I don't need to simplify. I guess I could simplify this. 4.5 plus 2 is going to give me 6.5 minus pi over 2. And I don't need to do anything else because pi is 3.1 something divided by 2 is like 1.5. So really 6.5 minus 2 at the, it's all 2 is like over the value is 4. So now I know my absolute minimum, is at -4, and the minimum value is -1. So when it says what is the minimum value, the absolute minimum value, that's referencing the y value. So we can now go ahead and say, now that we have all that work there, we can now go ahead and say this. Give me 1 second here. Let me just boom. I just had to change my pad real fast because it was being weird. There it is. Okay, so the absolute minimum value of g on the closed interval, -5, 4. So writing this whole thing down, the absolute minimum value of g on the closed interval is -1. Bam. Because it's asking for value, that's the y value. And if you're just confused, you could say the absolute minimum value of g on the closed interval is -1, which occurs at x equals -4, just if you feel like you want to include both points, okay? With that being said, that concludes this free response. Thank you for